Exercise 3C is looking at transformations with, in particular, reflections. So previously we've known this as there being a negative at the front of the entire function or a negative at the front of the x. And this does two different reflections, so either a reflection in the x-axis or a reflection in the y-axis. Alright, we are using coordinate points again, so a reflection in the x-axis which switches about this line here, okay? So a reflection in the x-axis means that your y values are made negative. A reflection in the y-axis means that your x-axis are made negative. So we're flipping this way. So looking at the two situations here, reflection in the x-axis, again, is a switch here. And that means that our y value is negative. Reflection in the x-axis, a reflection in the y-axis, this here is actually incorrect, it should be here. Okay, a reflection in the y-axis, which would mean a negative x value. Again, we can use algebra, or we can use an algebraic method in order to, I suppose, do our calculations or create new equations. So in this particular case, we're looking at a square root function that's reflected in the y-axis. Note, a reflection in the y-axis means that the x value is negative. So our original coordinate point, or image and pre-image, become negative x, y. Again, we can create a new equation, so x new is equal to negative x, and y new is equal to y. Just like previously, we now rearrange this to get what x equals. So x is equal to negative x new, and y is equal to y new. And then substituting this into our original equation, and when we do this, we get out, rearranging, this negative should be inside, so we would get out root negative x new. That is a mistake. You'll need to fix up in your notes. Good. Alright, example 1. Determine the image when the graph of y equals x squared is reflected in both the x-axis and the y-axis. In the first case, when we're looking at in the x-axis, that means that our coordinate point xy, our y value is what gets negatived. So the y goes to negative y, and this is our new x and our new y. Creating our equations, we have x equals to x new and y equals to negative y new. And we would then rearrange that to get negative y new equals 1 on x new squared. Now, note I've just done a substitution, so y into here, okay, and x into here as well. We don't like negative y new. Again, we want y new by itself, so rearranging that would get y new is equal to negative 1 on x new squared. And that would be an equation when y equals 1 on x squared is reflected in the x-axis. We're going to do the same thing, but we're now going to look at a reflection in the y-axis. So we're going to take the coordinate point xy, and then when we actually do our reflection in the y-axis, it's an x value that becomes negative. So the pre-image is going to become negative. So negative x comma y, and that's our new x and our new y. We can create an equation where x new is equal to negative x. Rearranging that, you'll get x equals to negative x new. And y is just equal to y new. Substituting that into our original equation, we would get y new equals to 1 on negative x new squared. Now negative x new all squared, a negative times a negative is a positive, which means this negative in here actually just cancels out, which gives us an end result of y new is equal to 1 on x new squared, which is actually our original function. So a reflection in the x-axis, in the y-axis, sorry, doesn't actually change our equation for a truncus. That makes sense because if you remember, a truncus is one of these functions that's actually symmetrical on the y-axis or about the y-axis, so a reflection actually doesn't do anything to our equation.